Yep. Hello everyone, I'm Arvin from B2 Network, and our project is to build the most practical Bitcoin Layer 2 network. And next page, please. Yeah. What we are going to do is to expand the Bitcoin ecosystem by building the most practical Layer 2 network and bring builder culture back to Bitcoin ecosystem. And the core value we will deliver is bringing a Turing complete smart contract execution layer to Bitcoin and supporting all kinds of DApps like DeFi, NFT, SocialFi, and GameFi. And also it will be a EVM compatible layer 2. Next page, please. Next page. Yeah, so be the most practical layer 2, there are 4 pivotal traits. The first one is we must deliver high performance with a relatively low cost. And secondly, the security is always the top priority. We need to make sure that we carry the security level from Bitcoin layer 1 to layer 2. And also for the users, we need to support the continuous using of their current wallet like OKX wallet, MetaMask, and Unisat, etc. And users can access the layer 2 using their original BTC or ETH address so that they don't need to change their using behavior. That will contribute to a mass adoption. And also for the builders, it's very important that we have this platform that is attractive enough for the builders to easy to construct and migrate their DApps from other chains. Next page. Yeah, so in this page, I will introduce our technological architecture in details. As you can see, the main structure of our product concludes 2 layers. The first one is roll-up layer, and the second one is DA layer. The roll-up layer is quite similar to a traditional ZK proof roll-up on Ethereum, and the sequencers will order transactions, and ZK EVM will execute the transactions and generate state data, and aggregator will gather the roll-up transaction and the state data to provide the prover with information needed to generate a ZK proof for the roll-up. And also the sequencers will, back to this page. And the sequencers will also send the batch proposals to the decentralized storage nodes in the DA layer, where the storage nodes will store the transaction information copies. And also the storage nodes will run a program, a disprover program provided by B2 to generate a ZK proof for the storage information of the decentralized storage. These proofs will be sent to the B2 nodes. And on the other hand, we can see that the aggregators will also send the consolidated batch data, which are the transactions Merkle tree root hash to the B2 nodes, and also the ZK proof for the roll-up transactions. Yeah. So now the B2 node, still the previous page, yeah. So now the B2 nodes get roll-up data and the storage proofs from the decentralized storage nodes and the transaction Merkle tree root hashes and ZK proofs of the roll-up transactions from the aggregator. So the B2 nodes can conduct a cross-validation of the decentralized storage transactions and verify the transactions ZK proofs. After completing a series of validation procedures, as you can see from the middle of the right part, the Bitcoin committer module of B2 nodes will send 2 transactions to Bitcoin. So the first inscribes the roll-up information and proofs into TypeScript as B2 inscription recorded on Bitcoin, and the Bitcoin committer sends a SAS UTXO to the generated taproot public key of the TypeScript, permanently recording the roll-up data and proof on Bitcoin. And I believe this first step is quite similar with maybe other layer 2 tool or set chain solutions, but we take a step further. What we are going to do is to secure ensure the security, leveraging the Bitcoin layer 1 to confirm the rollup on the Bitcoin. So what we are going to do is that we will run B-Square nodes will transform the ZK proof verification program into a binary circuit, then generate opcode script, and finally produce circuit taproot commitment. The Bitcoin committer sends a set UTXO with the taproot commitment as an unlock script, using it as fraud proof for the rollup, and a time-locked challenge period will be initiated. And if a challenge, as you can see from the right part of the slide, and if a challenger successfully challenge, they will unlock the reward UTXO, and the rollup will be rolled back. Otherwise, the rollup will be finally confirmed on the Bitcoin. So we are not only writing data to Bitcoin, but also get the confirmation from Bitcoin. And this architecture's core is generating a ZK proof for the rollup, validating it off-chain, and recording rollup data and ZK proof verification commitment on the Bitcoin network, and completing a final confirmation through a challenge response protocol. And in the following slide, next page please. In the following slides, I will delve into some technical details, but due to the time limit, maybe not go to too details. So first, we will ensure the data availability, allowing recovery of all rollup transactions at any time from information recorded on Bitcoin. Next page, please. And secondly, as I mentioned before, our solution is not simply writing data to Bitcoin like other sidechain solutions. Rollups need to be confirmed on layer 1, using layer 1 to provide security assurance for rollup. And what we're going to do is performing a verification of ZK proofs off-chain, and then we transform the proof verification program into a arithmetic circuit, which in turn generates a gate circuit based on alternative denial gates, or also known as NOT AND gate. And these alternative denial gates are implemented using Bitcoin opcode script, and will write into type leaf and eventually converted into the type root, as you can see from the structure in the middle of the slide. Type root and then will be recorded on the Bitcoin network as fraud proof for the rollup, and a time lock challenge is provided following that, as I just described. Next page, please. And we also offer decentralized sequencer services, ensuring decentralization and preventing malicious actions by sequencers. Next page. Yeah, and as I mentioned, we need to make sure that developers and builders can migrate to our layer 2 to create the ecosystem seamlessly with us. So we will integrate EVM, allowing developers to rapidly develop their applications with existing knowledge and tools. Yeah. Next page. And for users, we will implement the account abstraction in the rollup layer, supporting Bitcoin, Ethereum, and even social accounts like email address for user interaction. And additionally, it enables gas fees to be paid by alternative assets or covered by the DApp developers. Next page. Yeah, we implement Bitcoin state at the same time, monitoring Bitcoin blocks and transactions through the Bitcoin indexer in B-Square nodes, and we offer a decentralized Bitcoin indexer for curing state, ensuring security through ZK proofs. Next page. And as I mentioned, at the first one of the first priorities, the transaction fees are low and won't increase with the number of transactions. Next page, please. Yeah, the go-to-market growth plan. I'm very glad to announce that our testnet is set to launch this week, and we already got more than 10 eco partners on board, and we will have all kinds of community activities to drive volume to our testnet in the coming week and during the Christmas. And after only about 1.5 months operation, we already got over over 40,000 followers and active members in our community. So as we are infrastructure builder, we are very open for all the collaborations with eco-partners and developers, and we look forward to collaborate with you. And for the fundraising, the first round is closed, and we will start next round in the following months, and we're also quite open to all the discussion with investors. So that's all for my presentation today. Thank you for having me here.